Hi, we're doing Module 8 of ENSA today, which is VPI and IPsec concepts. So we're going to look at VPN technology, we'll look at the different types of VPNs, and we'll look at IPsec in particular. So VPN technology. So virtual private networks create end-to-end private network connections over a public network. And so a VPN is virtual in that it carries information within a private network, but that information is actually transported over a public insecure network. A VPN is private in that the traffic is encrypted to keep the data confidential while it is transported across that public network. Okay, so the benefits of VPNs are that they support encryption such as IPsec and SSL or secure sockets layer to ensure network traffic between sites. Major benefits of VPNs are in the table, so cost savings. Every site just needs an internet connection, and then you can create these VPN connections. Security, so of course encryption authentication is handled by IPsec or something similar. Scalability, they allow organizations to use the internet, making it easy to add new users without adding significant infrastructure. And compatibility, they're implemented across a wide variety of WAN links, including broadband. Remote users can use these high-speed connections to gain secure access to corporate networks. Okay, so the two major options for VPNs are site-to-site or remote access. So a site-to-site VPN is terminated on VPN gateway, so from router to router on each LAN, and of course you've got the internet in between. And so the internal host actually, it's all completely transparent to them. They don't see that it's happened at all. While the other type, of course, is remote access VLANs, and so of course they're from a host to a VPN gateway. So remote access VPN is dynamically created to establish a secure connection between a client and a VPN terminating device. So some kind of VPN server or specialized firewall. Now, VPNs can be managed and deployed as either enterprise or service provider VPNs. So enterprise are a common solution for securing enterprise traffic across the internet. Site-to-site and remote access VPNs are created and managed by the enterprise using IPsec and SSL VPNs. With service provider ones, they're created and managed by the provider network. The provider uses MPLS at layer 2 or 3 to create secure channels between an enterprise's sites, effectively segregating the traffic from other customer traffic. Okay. Now, when it comes to remote access VPNs, there's a couple of options as well. So remote access VPNs let remote and mobile users securely connect to the enterprise network. Remote access VPNs are typically enabled dynamically by the user when required and can be created using either IPsec or SSL. A clientless VPN connection is basically the connection is secured using a web browser SSL connection. So the only client software is a browser. Now, of course, the problem with the SSL is that it will limit you to whatever you can access via a web browser. That's the major problem, I suppose. So with a client-based VPN connection, such as Cisco AnyConnect, secure mobility client must be installed on the remote user's end device, and of course it needs to be configured. But you can normally move a lot more traffic across those VPNs. All right, so SSL VPNs use the public key infrastructure and digital certificates to authenticate peers. The type of VPN method implemented is based on the access requirements of the users and organizations it processes. The table compares IPsec and SSL. So applications supported. So IPsec, pretty much anything that runs an IP packet can go through IPsec. With SSL, as I said earlier, it's just basically through web-based applications. Authentication is strong with IPsec, while it's moderate with the SSL. Encryption strength, again, strong with IPsec, moderate to strong depending on your settings, of course, for SSL. Connection complexity, certainly is more work to get an IPsec VPN running than it is an SSL one. And connection options, so IPsec is limited, only specific devices with specific configurations connect, while SSL, any host with a web browser that supports SSL is pretty much good to go. All right, site-to-site VPNs connect networks across an untrusted network such as the internet, and hosts send and receive normal unencrypted TCP/IP traffic through a VPN gateway. So the VPN gateway encapsulates and encrypts outbound traffic from a site and sends the traffic through the VPN tunnel to the VPN gateway at the target site. Receiving VPN gateway strips the headers, decrypts the content, and relays the packet toward the target host inside its private network. So as we said, it's all transparent. The host doesn't know that it was actually put through a VPN at all. All right, so GRE, or generic routing encapsulation, is a non-secure site-to-site VPN tunneling protocol. So the reason why we talk about GRE is it has some capabilities that IPsec can't do. And so it can do various multiple network layer protocols as well as multicast and broadcast traffic. So GRE does not by default support encryption and therefore does not provide a secure VPN tunnel. GRE packet can be encapsulated in an IPsec packet to forward it securely to the destination VPN gateway. The standard IPsec VPNs, non-GRE, can only create secure tunnels for unicast traffic. And so multicast and broadcast, hence routing protocols, you can actually, of course, tunnel it using GRE, then tunnel it using IPsec. And so that is why we bother. All right. So the terms used to describe the encapsulation of GRE over IPsec tunnel are passenger protocol, carrier protocol, and transport protocol. So the passenger protocol is the original packet that was encapsulated by GRE. And so that could be an IPv4 or IPv6 packet, a routing update, whatever. The carrier protocol is GRE, and so that does the initial encapsulation of that passenger protocol packet. And then the transport packet is the protocol that will actually be used to forward the packet. This could be IPv4 or IPv6. So we've got the original IP packet, then encapsulated into a GRE, and then encapsulated into an IPsec. Okay, and so we've got several layers of tunnel there, basically in diagrammatic form. So for example, branch and HQ need to exchange OSPF routing information over an IPsec VPN. GRE over IPsec is used to support the routing protocol traffic over the IPsec VPN. Specifically, the OSPF packets, the passenger protocol, would be encapsulated by GRE, the carrier protocol, and subsequently encapsulated in a IPsec VPN tunnel, which of course is the transmission one. Okay, so dynamic multi-point VPNs. So site-to-site IPsec VPNs and GRE over IPsec are not sufficient when the enterprise adds many more sites. Dynamic multi-point VPN, or DMVPN, is a Cisco software solution for building multiple VPNs in an easy, dynamic, and scalable manner. And so it simplifies the VPN tunnel configuration and provides a flexible option to connect a central site with branch sites. It uses a hub and spoke configuration to establish a full mesh topology. Spoke sites establish secure VPN tunnels with a hub site. Each site is configured using a multi-point generic routing protocol, routing encapsulation. And that tunnel interface allows a single GRE interface to dynamically support multiple IPsec tunnels. Spoke sites can also obtain information about each other and alternatively build direct tunnels between themselves, so spoke to spoke, hence the full mesh. All right. So an IPsec virtual tunnel interface. So with the VTI, simplifies the configuration process required to support multiple sites and remote access. The VTI configuration is applied to a virtual interface instead of a static mapping, and the IPsec sessions to a physical interface. IPsec VTI is capable of sending and receiving both IP unicast and multicast encrypted traffic. Therefore, routing protocols are automatically supported without having to configure GRE tunnels. IPsec VTI can be configured between sites or in a hub and spoke topology. Okay, so service provider MPLS VPNs. So service providers use MPLS in their core network. Traffic is forwarded through the MPLS backbone using labels. Traffic is secure because service provider customers cannot see each other's traffic. MPLS can provide clients with managed VPN solutions. Therefore, securing traffic between client sites is the responsibility of the service provider. There are two types of MPLS VPN solutions supported by service providers. So layer 3 or layer 2. So layer 3, the service provider participates in customer routing by establishing a peering between the customer's routers and the provider's routers. With layer 2, the service provider is not involved in the customer routing. Instead, the provider deploys a virtual private LAN service to emulate an Ethernet multi-access LAN segment over the MPLS network. No routing is involved. The customer's routers effectively belong to the same multi-access network. Okay, IPsec. So IPsec is an IETF standard that defines how a VPN can be secured across IP networks. IPsec protects and authenticates IP packets between source and destination and provides these essential security functions. So confidentiality, so it uses encryption algorithms to prevent cyber criminals from reading the packet contents. Integrity, so uses hashing algorithms to ensure that packets have not been altered between source and destination. There's origin authentication, so it uses IKE protocol to authenticate source and destination, and Diffie-Hellman is used for secure key exchange. All right. So IPsec is not bound to any specific rules or any specific protocols. It's basically a framework that you plug whatever you choose into it. So IPsec can easily integrate new security technologies without updating the existing IPsec standards. The open slots in the IPsec framework shown in the figure can be filled with any of the choices that are available for that function to create a unique security association, or SA. And so you've got authentication header, ESP, which is of course your payload, and then, or you can have both. With confidentiality, what encryption are we using? So 3DES, AES, SEAL. DES is pretty old. Integrity, so it's an MD5 or a SHA hash. Authentication is pre-shared key or RSA. And then there's several Diffie-Hellman options for sharing keys. Okay. So choosing IPsec protocol encapsulation is the first building block for the framework. So it encapsulates packets using either authentication header or encapsulation security protocol. And so the choice of AH or ASP establishes which other building blocks are available. So AH is appropriate only when confidentiality is not required or permitted. ESP provides both confidentiality and authentication. Well, the letters have come off that, but anyway. So, confidentiality. The degree of confidentiality depends on the encryption algorithm and the length of the key used in that algorithm. The number of possibilities to try to hack the key is a function of the length of the key. The shorter the key, the easier it is to break. And so, basically here we're showing that using a key plus an algorithm, you can encrypt the data, go through there, then any threat actors can see it, but they won't understand what the hell's going on. And so I'll get there again using the key and that decryption algorithm. Of course, you can get the data back as it was. All right, confidentiality continued. The encryption algorithms highlighted in the figure are all symmetric key encryption crypto systems. So DES uses a 56-bit key. 3DES uses 3 independent 56-bit encryption keys per 64-bit block. AES offers 3 different key lengths, 128 through to 256. SEAL is a stream cipher, which means it encrypts data continuously rather than encrypting blocks of data. And SEAL uses 160-bit key. Now, SEAL, of course, is actually sort of specialized for running in software, while the others typically like to have hardware support. Okay, so integrity. Data integrity means that the data has not been changed in transit. A method of providing data integrity is required. So hashed message authentication code is a data integrity algorithm that guarantees the integrity of the message using a hash value. Message MD5 uses 128-bit shared secret key, while SHA uses 160-bit. So MD5 is getting long in the tooth, but still respected, but SHA is better. All right, so when it comes to authentication, there's 2 options there. So a pre-shared key, and so you manually enter a key into both hosts. Easy to configure manually, does not scale well, must be configured on every peer. While RSA authentication uses digital certificates to authenticate the peers. Each peer must authenticate its opposite peer before the tunnel is considered secure. Okay, so secure key exchange with Diffie-Hellman provides allows two peers to establish a shared secret key over an insecure channel. So variations of Diffie-Hellman key exchange are specified as DH groups. So 1, 2, and 5 are no longer used. 14, 15, and 16 use larger sizes of keys. And groups 19, 20, 21, and 24 use key sizes of 256 and so on. And they support elliptical curves cryptography, which reduces the time needed to generate keys. Okay, that's the end of the chapter. So what have we spoken about? So a VPN is a private in that the traffic is encrypted to keep the data confidential while it is transported across a public network. And so VPNs can give you cost savings, security, scalability, and compatibility. Remote access VPNs let remote and mobile users securely connect to the enterprise by creating an encrypted tunnel. Remote access VPNs can be created using either IPsec or SSL. Site-to-site VPNs are used to connect networks across an untrusted network such as the internet. And a site-to-site VPN hosts send and receive normal unencrypted TCP/IP traffic through a VPN terminating device, or sometimes called a VPN gateway. DMVPN is a dynamic system, allow you to build multiple dynamic scalable VPNs, and so it simplifies the configuration process required to support multiple sites and remote access. IPsec protects and authenticates IP packets between source and destination. Can protect data traffic from layer 4 through to 7. Using the IPsec framework, IPsec provides confidentiality, integrity, origin authentication, and Diffie-Hellman key exchange. IPsec encapsulates packets using AH or ESP. The degree of confidentiality depends on the encryption algorithm and the length of the key used in the encryption algorithm. DH provides a way for two peers to establish a shared secret key that only they know, even though they are communicating over an insecure channel. And there's a logo. So that's it for chapter 8, and I'll get back to you with a later chapter shortly. Have a good one.